The push or pull exerted on an object. Force. In simple terms, force is what makes an object start moving, stop, or change direction. Imagine you're trying to get a reluctant friend to join you for a walk, and they are hesitating at the door. Convincing them to leave the house requires a gentle push or pull, just like a force acting on an object. In both cases, the key similarity is that a push or pull is necessary to initiate movement or change position. Your friend's hesitation is like an object at rest, which needs that little bit of encouragement to start moving. Much like how an object requires a force to overcome inertia and change its state. Forces that are equal but in opposite directions. Balanced force. In science, a balanced force means that an object stays still or continues to move at the same speed in the same direction because the forces acting on it cancel each other out. Imagine trying to push a large, heavy table across your living room floor while someone else is trying to push it back in the opposite direction with the same amount of force. This scenario is similar to balanced forces because despite both of you exerting effort, the table remains stationary since the forces cancel each other out. Just like the table, when forces are equal in magnitude but opposite in direction, they create a standstill, demonstrating a state of balance where no movement occurs, akin to a tug-of-war resulting in a draw. The force that causes an object to move in a circle. Centripetal force. It is the inward force that keeps an object moving in a circular path. Imagine you're at a crowded party trying to keep a group of friends together as you navigate from one side of the room to the other. Just like you need to gently hold onto your friends' hands to keep them moving in a circle around the room with you, centripetal force is the hand that keeps an object moving in a circular path. The way you guide your friends, pulling them just enough to keep them from wandering off, is similar to how centripetal force pulls an object towards the center of its circular path, preventing it from flying off in a straight line. The force that opposes motion between two surfaces that are touching. Friction is the resistance you feel when you slide one object over another. Imagine trying to slide a heavy couch across a carpeted living room floor. This struggle is similar to the concept of friction, which is the force that opposes motion between two surfaces that are touching. Just as the resistance from the carpet makes it difficult to move the couch, friction acts as a resisting force that slows down or prevents the sliding motion between two surfaces, like the couch and the carpet. Imagine trying to slide a heavy couch across a carpeted living room floor. This struggle is similar to the concept of friction, which is the force that opposes motion between two surfaces that are touching. Just as the resistance from the carpet makes it difficult to move the couch, friction acts as a resisting force that slows down or prevents the sliding motion between two surfaces, like the couch and the carpet. This struggle is similar to the concept of friction, which is the force that opposes motion between two surfaces that are touching. Just as the attractive force between all objects that have mass. Gravity is a force that pulls objects toward each other, like how Earth pulls us toward its surface. Imagine you're trying to organize a group of friends for a dinner party, and everyone naturally gravitates toward the friend they're closest to. This situation is similar to gravity, because just as people tend to gather around those they have strong connections with, Objects with mass are drawn to each other due to gravitational attraction. In this analogy, the people are like objects with mass, and the closeness or friendship is akin to the gravitational pull that attracts objects to one another, highlighting how gravity is the invisible force that keeps everything connected, just like social bonds keep friends together. Measure of the force of gravity on an object. Weight. Weight is how much gravity pulls on an object. Imagine you're trying to push a shopping cart that's heavier than usual because it's filled with groceries. Just like the cart feels heavier and harder to push, an object's weight is the measure of the force that gravity exerts on it, making it harder to move. In both cases, whether it's the cart or an object on Earth, the heaviness you experience is due to the gravitational pull acting on the mass inside the cart or the object, creating a force that we refer to as weight. The force that opposes objects moving through the air. Air resistance. Air resistance is a type of friction that slows down objects as they move through the air. Imagine trying to walk through a crowded room where everyone is moving in different directions. Just as people in the room slow you down by blocking your path and causing you to navigate around them, air resistance acts similarly by opposing the motion of objects moving through the air. In this analogy, the people in the room represent air molecules that create resistance, making it harder for you or any object to move smoothly and quickly through the space. The product of an object's mass and velocity. Momentum. Momentum is a measure of how much motion an object has and how hard it is to stop. Imagine trying to push a heavy shopping cart that's already rolling quickly down a supermarket aisle. Just like the difficulty in stopping or changing the direction of that cart depends on how heavy it is and how fast it's moving, an object's momentum is determined by its mass and velocity. In this analogy, the shopping cart represents the object, its weight is the mass, and its speed down the aisle is the velocity. Together, these factors make it harder to stop, just as mass and velocity combine to create momentum. The friction that occurs when one solid surface slides over another, sliding friction. Sliding friction is the resistance you feel when you push an object over a surface. Imagine trying to drag a heavy suitcase across a carpeted floor at the airport. Just as the suitcase encounters resistance and doesn't glide smoothly due to the carpet's texture, sliding friction occurs when one solid surface meets resistance while moving over another. This resistance between your suitcase wheels and the carpet is akin to sliding friction, where the irregularities of both surfaces interact and slow down the movement, making it harder to slide smoothly. Friction that acts on objects that are not moving. Static friction. Static friction is the force that keeps an object at rest and prevents it from moving against a surface. Imagine trying to push a heavy couch across a carpeted living room and it just won't budge. This struggle is similar to static friction, which is the resistance you feel when the couch, or any object, isn't moving. Just as the couch resists your push due to the grip between its legs and the carpet, static friction is the force that keeps stationary objects in place by gripping them tightly to the surface they rest on, preventing any initial movement until a sufficient force is applied. The tendency of objects to resist any change in motion. Inertia. Inertia is an object's natural resistance to changes in its speed or direction. Imagine trying to push a heavy sofa across your living room floor. Just like the sofa resists your initial push and prefers to stay at rest, objects resist any change in motion due to inertia. The sofa's resistance to your effort is akin to an object's inertia, where it prefers to maintain its current state, whether at rest or in motion, unless acted upon by an external force. The amount of matter in an object, mass. Mass is how much stuff or matter is inside an object, determining how heavy it feels. Imagine trying to determine how much food you have left in your pantry without opening every can and box. Just like you rely on the weight of the items to estimate their contents, mass is the measure of how much matter an object contains without needing to look inside. In this analogy, the amount of food represents the matter, and the feeling of heaviness when you lift a can or box corresponds to the mass, helping you gauge the quantity without direct examination. The motion of a falling object when the only force acting on it is gravity. Free fall. In science, free fall is when an object falls solely under the influence of gravity, with no air resistance. Picture the feeling of losing control when you accidentally drop an ice cream cone on a hot day. Just as the cone descends rapidly toward the ground, with no other forces acting on it but gravity. This is similar to an object in free fall. In both scenarios, the ice cream's descent and a free-falling object, like a stone dropped from a height, experience a similar journey, moving solely under the influence of gravity, unimpeded by any other forces, until they inevitably meet the ground. Part of a wave where particles are pushed together. Compression. Compression is when particles in a medium are squeezed tightly together, creating a region of higher pressure in a wave. Imagine being in a crowded elevator where everyone is pressed closely together. This situation is similar to the compression part of a wave, where particles are pushed together tightly. Just like how people in the elevator have less space to move and are packed in a confined area, compression in a wave involves particles being squeezed closely together, reducing the available space between them. The sum of all forces acting on an object is called the net force. Net force is the overall force that determines how an object moves. Imagine trying to push a heavy sofa across a living room by yourself while your friend playfully pulls it in the opposite direction. This situation is similar to the concept of net force, because just like the sofa's movement depends on the combined effect of your push and your friend's pull, an object's motion depends on the sum of all forces acting on it. In this analogy, your push represents one force, your friend's pull represents another, and the sofa's eventual movement or stillness is determined by the net force, which is the sum of both your efforts. Forces acting on an object to cause a change in motion. Unbalanced force. An unbalanced force occurs when different forces on an object are not equal, causing the object to move. Imagine trying to move a heavy piece of furniture across a carpeted floor by yourself. This is similar to the concept of unbalanced forces, because just like how you exert effort to overcome the resistance and change the furniture's position, unbalanced forces act on an object to change its motion. In this analogy, your push represents the unbalanced force. The furniture is the object, and the carpet's resistance is like the opposing force that needs to be overcome for motion to occur.